Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question from 2019, time zone 2 in May, so question number 18. One of the really tricky question that I think in that particular year. So that is question number 18, locating on topic 6 again, so that is kinetics, asking for a really common diagram that students should have heard of it, so-called the Maxwell-Boltzmann distribution curve, in terms of showing the molecular speed of the molecules in that compound with a distribution of speed. Let's see. They're asking the same amount of two gases, namely X and Y, are in two identical containers. That means they're in almost the same environmental condition, and very important, at the same temperature. This is the key idea for this question. At the same temperature. That means temperature-wise, they're not going to be different. So what is the difference between the gases? Right? So that means we're now finding something that is different. First of all, after recognizing this shape, students should have realized that, particularly if we want to sketch another curve across the Maxwell-Boltzmann distribution, supposedly we have learned that that is symbolizing that the temperature of the gas Y is now higher than gas X, right? But then assuming the given condition is that under the same temperature, and what temperature shows, a really important kinetics idea, is that temperature is reflecting the average kinetic energy. So this basic concept, a little bit related to physics, but still students are required to know this foundation from topic 1 in terms of the kinetic theory. Temperature is a parameter that demonstrating the average kinetic energy of particles at that time. So that's why assuming you have the same temperature, that means the average kinetic energy between X and Y should be the same, but not any difference. So not C and not D. So next, that means we need to think of how about molar mass, right? And then the easiest way that we think of molar mass is to think of the equation behind what is meant by kinetic energy. So symbol Ke. So Ke means kinetic energy. It's a little bit physics, but this is going to be easy if we look at the equation. The Ke is actually demonstrated as half times the m times v squared. The m stands for the mass and the v stands for the velocity. Simply says this is going to be the molecular speed, right? So in this case, assuming that the average Ke is going to be the same as well, right? Because they have the same temperature, and just mentioned temperature reflects the average Ke, so I'm assuming they have same temperature, so average Ke should be the same. So that means this average Ke will then be the same as well. But then for this diagram, we can spot out that what is going to be different between X and Y is that the molecular speed for Y is generally bigger than the molecular speed for X, right? As we can see, the peak value, that means the majority of the particles are now having a relatively higher speed with more slants to the right hand side, right? But for X, the majority is still staying on the area in which the molecular speed is lower. So this is the first impression or first interpretation from that diagram. That's pretty makes sense. So which means for the case of Y, it is going to be having a higher V value. For X, is going to be having a lower V because the V stands for the molecular speed. So that means if they are having the same value finally, so that shows that for mass speaking, the X should be greater, in other words, in order to compensate these two magnitudes. And so finally, the Ke for X and the Ke for Y is going to be the same, right? In other words, maybe I apply into two of the scenarios. The first, which is going to be Ke equals to half m, then that will be X, and V, that will be X as well, so V squared. And also for the Ke, that is half of the m V squared as well, but that will be Y, and V for the Y as well. And by the previous interpretation, the average Ke is the same, that means these two numbers, no difference, the same value. And half is just a constant, so ignore it. And then we just figure it out. The speed for Y is going to be bigger than the speed of X, so that means for these comparison, the Vy is going to be bigger than the Vx, right? So that's after the squaring, still the same result. The Vy is going to be bigger than the Vx. So that means in terms of the mass, the Mx must be bigger than the My. Otherwise, you can't compensate these two factors and say at the result that the both Ke are the same, right? So this is just a simple mathematical expression. Because in one of the battle, that the velocity wins. So that's why in the other battle, the mass and other side must be winning back. Otherwise, that you cannot say that they are having the same kinetic energy, right? So that's why in terms of this idea, we can deduce the mass of the X is going to be bigger than the mass of the Y, and this mass is said to be the molar mass, right? So at the end, the simple understanding is that the X is going to be winning back for the mass value. So that's why you can have the same kinetic energy applied it as same temperature. So that's why answer for this question will then be A.